Welcome back, everyone. In this lecture, we're going to go through the solutions for the neural network exercises. Let's get started. Okay, here we have the exercise notebook opened up. Let's go ahead and go through it. So the first thing we want to do is perform these standard imports and read in our data set. So I'll go ahead and run in these first few cells that have already been defined for me. You can see here I did my imports, read in the data, saw the data set, explored it a little bit, and you can take more time exploring it if you're not familiar with it. And then we can see here our value counts. So what we'll go ahead and do is we'll first separate continuous, categorical, and label column names. So if you run df columns, you'll see the names here that are easy to access. That way you can just kind of copy and paste, and you can confirm their spelling. And what we want you to do is essentially code here what the correct answer should be. So let's go ahead and create those variables, cat calls, for our category columns. And if you take a look at the data, you should have realized that the sex column is categorical. The education column is also categorical. Then the marital status is also categorical. And then we have work class as another one. And then finally, occupation. And then for our continuous columns, which we'll call cont COLS, we'll go ahead and say age, and then hours per week. And whoops, that should be a dash, not an equal sign. So we have age, hours per week as our two continuous ones. And finally, for our label, we'll say y column is equal to, and this one you should choose label. So go ahead and run that. You should see now this confirmed 521, just as we have here 521. Next, what we want to do is convert the categorical columns to the pandas category data type. To do this, we can simply loop through that list of columns. We can say for cat in cat columns, go ahead and grab that particular column from the data frame and set it equal to that particular column as type category. So we'll go ahead and run that. And then the next one, we wanted to shuffle the data set. This was optional. It was technically already shuffled. But you can go ahead and run this so you get the exact same configuration we do. Then we wanted to set the embedding sizes. So the way we do that is essentially we can use the same list comprehension that we showed during the lectures. So I'll say that my categorical sizes is equal to the length of, and then we'll say data frame column dot cat dot categories for column in cat calls. So essentially for every one of those categorical columns, I will take that column, grab .cat .categories from it, and then check the length of that. And then that's the number of categories I have, and then I can use that to set my embedding sizes. And we pretty much showed this code and explained this code during the ANN lectures. So if you're still not kind of understanding what's going on here, make sure you review those lectures. And what we'll do here is we'll say size and take the minimum. It's either going to be in between 50 or size plus 1 with a floor division with 2. And then we'll go ahead and say for size in category sizes that we made. Let me make sure my parentheses are balanced here. We have size, minimum, and this one has got an extra. There we go. Okay, so I'm gonna put one there, here, and here. Okay, so now my parentheses are balanced. Let's go ahead and confirm that, run that, and we get back the same embedding sizes we have here in our solutions. Perfect. Then we'll go ahead and create an array of categorical values. So the way we can do that is through the following. I'll make little kind of shortened variables here. So we'll say dfsex, and then I'm going to say from the category, grab the codes, and then grab those values. This is essentially kind of the first step before we one-hot encode all these categories. And then we'll do the same for education. So we'll say, education. You should be able to autocomplete these with tab. We'll say MS for marital status. Then we'll say the working class, so df work class, and then OC for occupation, df occupation, and finally let's patch on those cat code values. So I'm just copy and pasting that in. make a list of those. So we'll say cats is equal to, and then we'll stack these on top of each other using NumPy. So we have SX, ED, MS, WC, and then OC, and we want to make sure we do this along axis equal to 1. Go ahead and run that, compare that to the results, and you should see them match up. Something to keep in mind, if they don't match up exactly with the solutions, it's because the solutions may have been shuffled differently than what you shuffled, and it really depends on whether or not you ran this optional shuffle the data set. However, for the most part, you should get kind of the same results here. We can see that the categories on the first one, there is 0 or 1, so we have 0 or 1 here. You can see on the next column, they're kind of 10, 12, 13, etc., 10, 11, so they run from 1 to 13 or something. We can see 3, 1, 0s, etc. So they may not match up exactly. However, the idea is still the same, right? We went ahead and got our category, those code values, and put them together into a large NumPy array for the next step, which is to convert them into a tensor. So let's go ahead and do that using PyTorch by simply saying cat is now equal to torch.tensor, and we'll say cats, where dtype is equal to torch integer 64-bit. Go ahead and run that. And then the next thing we want to do is create an array of the continuous values. And we can do this in one line, as we mentioned during the lectures. So the one line here is just going to be continuous is equal to np stack. And it's up to you if you want to separate this into multiple lines. But here we'll say df of that column, grab those actual values for every column in the continuous columns list. And then we want to stack it along axis is equal to 1. So run that, and you should get similar behavior to what you see here. Again, these may not match up exactly depending on what shuffling you chose. Next, we wanted to convert the const to a tensor, so that's kind of the same thing. We'll say const is equal to torch.tensor, passing those continuous, and we'll say dtype is equal to torch.float. Run that, and we confirm the same data type. Next, we want to create a label tensor, so that's just the y label, and we'll say torch tensor df y column dot values, and then we're going to go ahead and if you just run this and you check out y itself, you get this sort of result. However, we also mentioned that because this is classification, you want to make sure to flatten the tensor so it can be passed into the loss function. So we'll go ahead and say flatten here, and that way we have it flattened out. So this is what the cross-entropy loss function is expecting in order to compare its labels. So next we want to create the training and test sets, and what we're going to do here is we have a suggested batch size and test size, so we'll go ahead and use those suggestions, and then we'll just split them up. We'll say our categorical training, our categorical test, our continuous training, and our continuous test, and then our ytrain and ytest. Let's go ahead and set those equal. And then we'll say cats, starting from the beginning, all the way to the batch size minus the test size. Cats, starting at the batch size minus the test size, all the way to the batch size. And then same for continuous here. So from the beginning, go to the batch size minus the test size. For the test set, we'll go from the batch size minus test size, all the way to the batch size. And then we'll say y, same thing here for training. So training starts from the beginning, then goes all the way to, batch minus test. And the reason we can do that is because, remember, we already shuffled these. And then we'll say batch minus test, all the way to the batch size. Okay, go ahead and run that. And then we'll go ahead and define the model class. Essentially, this is all the same that we've saw in both ANN lectures. Go ahead and run that. You can set the random seed. So if you want to get kind of the exact same results as the solutions notebook, you can set a random seed. It's kind of technically optional, but we'll go ahead and do it. So I'll set a manual seed of 33. So now I have my generator for that seed ready to go. Next one I want to do is create a tabular model instance. So we'll say model is equal to the tabular model. Go ahead and pass in the embedding sizes, the const shape 1, which is essentially the number of continuous variables or continuous features. We have a binary classification, so if we take a look here, the output size, that should be 2. And it's up to you how many neurons. We went ahead and said, go ahead and make a hidden layer containing 50 neurons. So we'll choose that, just one layer, 50 neurons. And then the dropout probability will be 40%, so 40% of them turn off during training. And then if you say, ask for the model back, you should get the same results here. Next, we want to define the loss and optimization. So what we'll say here is criterion is equal to nn dot cross entropy loss, because it's classification. And for our optimizer, we will say torch.optim, call atom, pass in those model parameters with a learning rate of 0.001. Run that. Now it's time to train the model. We set it up here for you for 300 epochs. You can play around with that value if you want. Feel free to play around with any of this, but essentially it's going to be the same. You check out the time, and I'm going to go ahead and run this. And whoops, looks like we have it here as contrain instead of continuous train. I'll go ahead and just fix that with contrain. Now I'll run this again. All right, so this is now training. I'm going to fast forward in time until this is done training. All right, so it finished training for me. Took 113 seconds, so a little less than 2 minutes. I have a really fast computer, so if your computer's slower, it may take a little longer. If you have a faster computer than me, it may take less time. Next, what we want to do is plot the cross entropy loss against the number of epochs. So if you take a look at the actual code, we were already tracking the losses right here. So we'll go ahead and plot that out. We can say this with plt.plot, and then for range in epochs as x. And then we'll go ahead and say losses, and there we get kind of similar behavior. That starts to converge kind of past 200, starts to really slow down. Okay, then we want to evaluate on the test set. So how do we do this? We'll say with torch, no gradient update there. We'll say yval is equal to the model, and then pass in the categorical test data, and then we'll pass in our continuous test data. And we want to compare that loss to the real values. So we'll say grab that criterion against yval and ytest, and this reports back your cross entropy loss. However, you're probably more interested in things like accuracy. So let's go ahead and calculate the overall percent accuracy, since that's much easier to interpret, and it's actually useful to us. So lots of different ways you can do this, but I'll go ahead and show you one way of doing it. I'll define rows as the length of my test set, so ytest. And I'll start off by keeping track of how many I get correct. So I start off with 0 correct, and then we'll say for I in range rows, or the length of the test set, I will say if yval of I argmax item is equal to that ytest value, then I have a match. So I'll go ahead and say correct, add 1 to that count. And finally, in order to actually print out the number I got correct, I can say 100 times the number I got correct divided by the number of rows. So this is my percent correct. In fact, let me do this in a separate line. There's lots of different ways you can do this, but we'll say percent correct is equal to that calculation, and then we'll go ahead and print that out. So if you run that, you should get back somewhere around kind of 85% correct, maybe plus or minus 5%. If you don't get back exactly 85.1, that's totally okay. It's because the random shuffling was different during the creation of this notebook. But you should get kind of plus or minus 5% off 85%. Now, this could change if you didn't train it for as many epochs as we did, or if you shuffle the data differently, etc. And then bonus, if you want, you can feed in new data through the trained model. This is a lot of code, and essentially you can kind of copy and paste it from what we did for our ANN lectures. And it's enough code that I'm going to copy and paste it here and just quickly explain what's going on in it. It's essentially just repeating everything we did earlier. So I'm just copy and pasting it and then explain what's going on here. Essentially, we take everything as an input, and if we expect it to be a float, we go ahead and transform it because the input function converts everything to a string, and then we'll go ahead and capitalize some of these so that it's in the exact same format as the data frames data. If it's even slightly different, like a lowercase m versus a capital M, it's not going to be able to run through the same sort of code that we just did, because then it'll think that there's 3 sexes or something, lowercase m, capital M, and then capital F. So you have to make sure it's in the exact same format for a lot of these things. So we take in all the inputs, we pre-process the data using these dictionaries, then we'll go ahead and grab from these dictionaries the actual values that were passed in. So for example, if they said, so, what's the person's sex, male or female, and then we check out our sex dictionary, female is 0, male is 1, then we'll say, okay, what is the value of that sex dictionary at female? We get 0, and then we have sex as the value of 0. We go ahead and create those tensors. Then we set our model to eval in case this hasn't already been done, pass in the new data through the model, so torch no grad, and then we have our model here, cats continuous, argmax item, and we get back the prediction. Okay. If you have any questions on that, you can check out our ANN lectures. But that is essentially now your exercise project. So I want to point out you should now be able to take any tabular data set, regardless if it has continuous or categorical features or both combined, and regardless if it's a regression task or a classification task, you should now be able to use all the code that we've shown here and in the ANN notebooks as blueprints in order to run artificial neural networks on your own supervised problems like regression and classification. Thanks, and we'll see you at the next section of the course.